Module 3, Lesson 19, Problem Solving and the Coordinate Plane. Learning targets. I can solve problems related to the distance between points that lie on the same horizontal and vertical line. And I can use the coordinate plane to graph points, line segments, and geometric shapes. We are going to start by locating and labeling our points of 4 and 5 and 4 and -3. Now that we have located and labeled our points, we are going to connect our 2 points together to form a line segment. Now we're going to find the distance of this line segment. And since our x-coordinates are the same, we're going to be using our y-coordinates. And this goes back to what we did in yesterday's lesson. Because our y-coordinates are on opposite sides of 0, we are going to be adding our numbers together. So we're going to have the absolute value plus the absolute value of -3, which becomes 5 plus 3, which gives us a distance of 8 units. So now we're going to find a line segment that has a length of 9 units that starts at our point of 4 and -3. So we're going to go from our point of 4 and -3, and we're going to count 9 spaces or 9 lines, either to the left of that point or to the right of that point. So I have marked a point that is to the left of 4 and -3 at 5 and -3, and that's simply because that's where I had enough room on our coordinate plane. If we had a bigger area, we could have went to the right, and that coordinate would be 13 and -3. So you could have went in either direction, but from here on out, we're going to be using our coordinate of 5 and -3, and I have connected our line segment together. So our 2 line segments that we have just drawn could be seen as 2 sides of a rectangle. Given this, the endpoints of the 2 line segments would be 3 of the vertices of this rectangle. So what is the other coordinate that we would need to make this square complete? To make this square complete, we would need the point of -5 and 5. We know that it's going to need to be connected to our point of -5 and -3. So our x-coordinate would have to be the same. So that would be -5. And then that 4th point would have to connect to our point of 4 and 5. So our y-coordinate would be the same at 5. So our 4th point is -5 and 5. And I have gone ahead and connected our last 2 line segments to make our square. So now I have gone ahead and written in our lengths of each of our line segments. So we have 2 line segments of 8 and we have 2 line segments of 9. And the next thing we're going to do is we're going to find the perimeter of this rectangle. And when we are finding the perimeter of a rectangle or of a square, we're just simply adding up all the sides of the rectangle or the square. So we're going to have 8 plus 9 plus 8 plus 9. When simplified, this becomes 17 plus 17 for a perimeter of 34 units. So now that we found the perimeter of a rectangle, let's go ahead and find the area of a rectangle. And when we find the area of a rectangle, we are going to be using the formula A is equal to length times width. So we are only using 2 of the sides, where in the perimeter we are adding up all 4 sides. So our area is going to be equal to 8 times 9. So our final area is 72 units squared. And remember, you will always need a unit of measure. In this case, it's just units. And then area is always squared. So it's going to have that little exponent of 2 or that little floaty 2 in the corner. Now, what would happen if we were to draw a diagonal line segment through the rectangle with opposite vertices for endpoints? What geometric figure would we be creating? So I've drawn a diagonal line going from -5 and -3 to 4 and 5, and you obviously could have drawn a diagonal going from -5 and 5 to 4 and -3. But what geometric figure did we create by drawing this diagonal line? If you said triangle, you are correct. By drawing a diagonal line in a rectangle or a square, you are going to be creating two triangles. So now we're going to find the area of the triangles that we just created. And we're going to do this two different ways. So the first way we're going to do this is by using our area of a triangle formula. And our formula for area of a triangle is 1/2 base times height. So our base is going to be 9 and our height is going to be 8. And now we're just going to simply multiply going from left to right. So we're going to start by taking 1/2 of 9, and 1/2 of 9 is equal to 4.5, and then we're going to multiply 4.5 by 8. So we have an area of 36 units squared. And now here's the other way we could have solved this problem. So we know that the area of our rectangle was 72 units squared, and we created two triangles, and we only want to find the area of one triangle, so we could take the 72 units squared and divide it by 2. And when we do that, we get an answer of 36 units squared. So we got the exact same answer that we did when we were using our area of a triangle formula. So that's two different ways that you could have solved this problem. And lastly, we are going to be constructing a rectangle on our coordinate plane that satisfies some criteria. So our rectangle is going to have each of the vertices lies in a different coordinate. So we're going to have a point in coordinate 1, in coordinate 2, in coordinate 3, and coordinate 4. Its sides are either vertical or horizontal, so this tells us that we're making a rectangle for sure, even though in the directions it said we were making a rectangle. And lastly, our rectangle is going to have a perimeter of 28 units. So we know that a rectangle has 4 sides, so I'm going to start by taking our perimeter, which is 28 units, and dividing it by 4. And when we do this, we get a 7. So this just eliminates some guesswork, because I know that now we're making a square or a rectangle that has a length of 7 for each of its sides. So now we can go ahead and start placing our points. And from here, it doesn't really matter where we place our points as long as we have a point in each of our coordinates, and each line segment has a length of 7 units. So I have gone ahead and made our square, and it starts with points of 6 and 6, and then 6 and -1, and -1 and -1, and then -1 and 6. So now we just have to prove that this follows our criteria. And it should, because I took our perimeter and are divided by 4. But now we're just going to explain a little bit more on how this actually fits. So I'm going to go ahead and label our sides as A, B, C, and D. And now we're going to use absolute value to find each of the lengths of each side. So we have that side A is the absolute value of 6 plus the absolute value of -1, which is 6 plus 1, which equals 7. Side B, absolute value of 6 plus the absolute value of -1, which becomes 6 plus 1, which equals 7. Side C, the absolute value of -1 plus the absolute value of 6 is equal to 6 plus 1, which equals 7. And side D is the absolute value of -1 plus the absolute value of 6, which is 6 plus 1, which equals 7. And now we're going to take up all our 7s, and we're going to add them all together to find the perimeter. And when we chunk this together, it becomes 14 plus 14, which equals 28 units. So our rectangle square fits the criteria that we were given. Lesson summary. The length of a line segment on the coordinate plane can be determined by finding the distance between its endpoints, and you can find the perimeter and area of figures such as rectangles and right triangles by finding the lengths of the line segments that make up their sides and then using the appropriate formula. And that's it. You have reached the end of this lesson and the end of Module 3. So now it is your turn to go and try the problem set.